Hello, my little mathematicians. Today, we're going to explore the independent versus dependent variable when dealing with tables and graphs. Okay, so if we take a look at this first problem, it says Vivian earns money for each box of cookies she sells. The table to the right, right here, shows how much money she earns for each box sold. What they want you to do is they want you to complete the graph by labeling the independent and dependent variables on the graph on the proper axis. So which one is the x and which one is the y. Okay, then graph the points from the table and then draw a line to connect your points. Okay, so first off, let's go ahead and label which one's what. Which one's the independent and which one's the dependent variable. One way to remember what's what is our equations are usually, you'll notice later that they're going to be y equals something times x. Okay, so y is like your answer. So your answer depends upon what you do to x. Okay, so y is the dependent, which makes x the independent. So you do something to the x, and whatever you do to that, it affects your dependent variable, your y. And then when you're looking at a table, I'd say like 99% of the time, x is always first and y is second. Okay. I don't know why, but I can't guarantee 100% of the time, but I'd say 99% of the time, x is always the thing that's first in your table and y is always the second thing. And then let's kind of see if that makes sense. So does your answer y depend upon this x? How much money you earn depends upon how many cookies you actually sell. Yeah, that makes sense. That this depends upon that. Okay, so then let's label y is always your vertical axis and x is always your horizontal axis. Okay, and how I remember is when you're looking out on the horizon, you kind of hold your hand like flat to your forehead. Do it right now. Hold your head flat to your forehead. You're looking out over the sea to see the horizon and you're blocking out the sun. What shape is your hand making? It's making a perfectly horizontal line. So when you want to look out at the horizon, you make a little a horizontal line with your hand, put it over your eyes to shield out the sun. Okay, so X is your horizontal axis, Y is your vertical axis. So we're going to label Y as the money earned, and we're going to label X as the cookies sold. Okay, so I labeled the independent, dependent variables in the graph. Done. Okay, graph the points. So X tells me how far over to go, and then the Y tells me up or down. So I'm going to go over nothing, up nothing. Then over 1, up 2. Over 2, up 4. Over 3, up 6. The only thing you want to watch out for is always double check what they're counting by, because sometimes it may be counting by 2s or 3s or 4s here. But luckily, each axis was just counting by 1s. So there we go. If you don't have a ruler to connect your lines, it's fine. You can actually just use a piece of paper. A piece of paper will work just as good as a ruler. Okay, so grab a piece of paper and then use that as your ruler to connect your lines. And there you go. Okay, perfectly straight line. How you know that you graphed your points correctly, we're going to be dealing with linear relationships, which have a constant rate of change. So it's always going to go up and over the same amount. So if you ever see a point that's off the line, relook at that point because it's probably not right. Okay, so now that I did that, I can use my graph to answer a question that wasn't on this table. According to your graph, how much money does Vivian earn after selling 5 boxes of cookies? Okay, so this is the number of cookies sold. So I'm going to find 5 and I'm going to see right here. Okay, and notice how my line actually maybe like it's hard to see because I didn't extend it very well. So I want to make sure that I maybe extend it carefully. Okay, some of you can already be like, yeah, it's good enough. I know what the answer is by looking at my line. But you always don't want to stop too soon. And you want to make sure that it is perfectly straight because sometimes they ask you a question just like this one. Okay, so now it's easier to see at 5 cookies sold, where does it hit? Right here, which is 10 on the y-axis. Okay, so you would make $10 if you sold 5 boxes of cookies. Okay, now a lot of times, like, that's helpful to just use your graph. That's why we do it. That way you don't have to do a bunch of math involved. Okay, or you can look at the table pattern. Okay, so if the number of cookies sold was 5 and you don't know how much money that is, look at the other patterns. How would you get from 1 to 2? Well, you could add 1 each time, right? Because 1 plus 1 is 2. Does that pattern hold up? 2 plus 1 is 3, not 4. So nope, I can't just add 1 to these values to get y. So what if I instead multiplied by 2 to get 2? 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 0 times 2 is 0. Perfect. So the pattern of multiplying your x times 2 gives me my y. So if there was 5 cookies sold, then I will have earned $10. So you could complete your table that way, but if you have a graph, why not just use the graph? Okay. Example 2 says, the table below shows how much money Agnes puts in her piggy bank each week. Okay, so here's the time in weeks. And then this is how much money I have according to which week it is. So at week 1, she had $1.50. Week 2, she had $3. Week 3, she had $4.50. Week 4, she had $6. So let's see. This is which one's my x and which one's my y? What do you think? Remember we said that x is usually the first one that comes, like 99% of the time, and then y is going to be the second one. And then think about it. Does it make sense? How much money you have depends upon how long have you spent saving. Yeah, it makes sense. And just a hint too, x is usually almost always time. Okay, and money is usually almost always y. Okay, now that we have that, I can label my axes. So I'm going to label my y-axis as the money saved. And then I'm going to label my x-axis as time. And we like to sometimes put the unit, like what amount of time, like what are we measuring it in? We're measuring it in weeks. Okay. So now that I have that figured out, let's go ahead and plot these points. So at 1 week, she had $1.50. I don't see that on here. But 50 cents is halfway between 1 and 2, right? So halfway between would be right there, halfway between the 1 and 2. So at 1 week, she has $1.50. At 2 weeks, she has exactly $3. At 3 weeks, she has $4.50. So halfway between the 4 and the 5. And then at 4 weeks, she has 6. Okay, now we want to draw a line to connect these, but as we learned from that previous problem, we want to extend our line as far as we can in case they ask us a future question, right? So let's make sure that that line is really straight. Okay, and let's see here. Want it to go through exactly those points. Okay. Oops. And there we go. Now I have a perfectly straight line. Okay. It says, according to your graph, how much money does Agnes have in her piggy bank after 6 weeks? So this is the axis with weeks. So at 6 weeks, find 6 weeks. Go up to your graph. That's right here. So go over to the y-axis. And how much money is that? $9. Isn't that nice that you can use your graph to figure out answers? Once you plotted these points that were given to you, then it's going to follow the same pattern. Okay. Remember, we always like you to try some on your own. So if you haven't tried any on your own yet, go ahead and try these, but I want to give you one hint. Note the axes. This is counting by 1. Is this counting by ones? Nope, it's counting by tens. Okay, go ahead and see if you can label which axis is what and then plot those points. Okay, you paused it, you unpaused it, you're back with us. Let's see how you did. Okay. We usually put X first, Y second. See if that makes sense. How far you go depends upon how long you've been traveling. Yep, makes sense. Okay. So right here, I'm going to label the Y axis as distance in miles. And then I'm going to label the X axis time in hours. Okay, and go ahead and plot those points. So at 1 hour, so go over 1, you've gone 30 miles. At 2 hours, you've gone 60 miles. At 3 miles, you've gone 90 miles. And at 4, you've gone 120. Oh no, it's off the graph. That's fine. Okay, just plot as many points as you can that are on the graph and then extend your line and we'll get the point. Okay. So I'm going to go ahead and connect these points using either a ruler or a piece of paper so that I can make my line nice and straight. And there you go. Okay, let's go ahead and take a look at the next one. Okay, we want to label X and Y. See if it makes sense for the problem. Cole goes on long jogs on the weekend. The table below shows how far he travels per hour. Well, how many miles he's gone depends upon how long into his walk he is. Okay, makes sense. So Y, again, is your distance in miles. I told you that distance and money is usually almost always the Y, and time is usually almost always your X. Okay, but this time instead of weeks like the previous page, we're in hours again. Okay, now I'm going to go ahead and plot these points. So I have over 1, up 6. Over 2, up 12. Over 3, up 18. And it's not on here. Okay, so I can't extend the line and figure out where 4 hit, but can I look at the pattern? What pattern do you see? Can you fill in the table according to the pattern? Each time this goes up by 1, this goes up by 6, right? So then if I were to take 18 and add another 6 to it, I'd get 24. And if I were to take 24 and add another 6 to it, I'd get 30. That's great when determining a pattern. However, you only go like, as this goes up 1, this goes up by 6. But what if this wasn't counting by ones up here? What if they like put random numbers like a 13 and then a 20 and then a 35, okay? And they're doing totally random. It's good to also see the relationship between the X and the Y. Do you notice a relationship going that way? What do you do to X in order to get the Y? You can add 5, okay? Yeah, 1 plus 5 is 6, but is 2 plus 5 12? So plus 5 doesn't work. What does work though? Yeah, times 6, right? If I do this times 6, 1 times 6 is 6. 2 times 6 is 12. 3 times 6 is 18. 4 times 6 gives me that 24. 5 times 6 is 30. And you're like, well, why? I liked it before. We already had the 24 and the 30. Like, I just know it went up by 6 each time, so I just kept adding 6. Why can't I do that? Because again, what if they asked you random numbers? Like, what if they put, okay, fine. If she was walking for, or if he was walking for 100 hours, how far did he go? Do you really want to do the math of like plus 6, plus 6, plus 6, plus 6 100 times? No, it's easier to find the relationship between the X and the Y. Okay. Don't forget to always graph the points by drawing a straight line. And I recommend using a ruler or a piece of paper so that it's straight, because as we've established before, sometimes you need that line to find a missing number. Okay. The next one says the table below shows how many calories Olivia burns from power walking. Okay, so let's see if the X first and Y second relationship works. How many calories you burn depends upon how long you've been exercising. Yep, makes sense. Okay, so Y is my calories burned. Calories burned. And then that makes X my time in hours. Okay, let's go ahead and graph those points. So in 1 hour, Olivia burns 50 calories. In 2 hours, she burns 100. In 3 hours, she burns 150. Okay, so notice how it's going like up 1, 2 over 1, 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 up 1, 2 over 1. It continues at a continuous pattern. So I could extend my line that way if you don't have a ruler as well. Okay, and now actually I can use that to see that 4 hits right here, which is 200 calories, and 5 hits right there at 250. Okay, and if you don't trust yourself to do that, or you don't trust yourself with the ruler, again, look for the relationship. How do you get from X to Y? Well, I can multiply by 50. 1 times 50 is 50. 2 times 50 is 100. 3 times 50 is 100. 4 times 50 is 200. And 5 times 50 is 250. Okay, multiple ways to go ahead and fill out that table. Notice how everything is interconnected. Okay, the table moves at a constant rate and has a relationship to each other. And then the table represents points on the graph, and it moves at the same consistent rate as that does. Okay, let's go ahead and try the next problem. This looks a little bit different, huh? It says Garth is saving money. The graph below shows how much money he saves each week. All right. They want you to fill out the table headings with the independent and dependent variable, fill out the table based off the points on the graph, and predict predict what's coming next. So let's see. So for here, which one's the X and which one's the Y? Okay. X is usually always first, and your X-axis is the horizontal one. So your number of weeks. Y is always the vertical axis. So this one, they told us it's the total money saved. Okay. And in the future, they might not even give us that hint. Okay. This is giving us a lot. Just from the word problem, we could have figured that out, because how much money he saved depends upon how many weeks he's been saving, right? Okay. Now let's go ahead and use the graph to fill out this table. So the first point that I see right here, what point is that? That's 0, 0, right? When X is 0, Y is 0. Okay, the next obvious point I see, like I can't pick this one because I don't know exactly where that is. It's somewhere between 0 and 1. Is that like a fourth, half, 3/4? I don't know. So I want to find an exact point that like meets right in corners. So that's an exact point. No, no. Aha. Exact point. No, no. Yes, exact point. There we go. Okay, so I can know when X is 1 and when X is 2 and when X is 3. Okay. Well, when X was 1, Y was 3. When X was 2, Y was 6. And then when X was 3, Y was 9. There you go. Okay. So this right here represents this graph. Okay. I used each of these points to fill out my table because that's what a table is. It represents an XY coordinate point. Let's look at this one. It says the graph below shows the height of a plant over time. Okay, Alex, Brian, and Claire all made tables to represent this. However, all of them are different. So do they all fill in the tables properly? If not, who did it correctly and who did it incorrectly? Okay, so what might be nice is maybe I want to identify some points on the graph. So I know that this point is 0, 0. No, this one is an exact point, and that represents over 2 up 1. No, but this is an exact point, and that represents over 4 up 2. No, this one. This one went over 6 up 3. No, this one. Over 8 up 4. Okay, and if you haven't tried to identify any points, make sure you try before I do it. Over 10 up 5. Okay. Remember that these are coordinate points representing x, y, x, y, x, y, x, y, x, comma, y, x, comma, y, right? And these are all x, comma, y, x, comma, y, x, comma, y. So what do you notice about the actual graph? Your y is always half the x, right? So 2 is half of 4, 3 is half of 6. Okay, half of 1, half of 2, half of 3, half of 4. 2 is not half of 1. No. Mm-mm. Okay, so Brian's table had the wrong way. So he probably switched it, I'm guessing. So right here, when he went to do his table, that first point is 2, 1, but he labeled it as 1, 2 instead. So he switched his x and y values. So he's incorrect. Okay, she did y is half of 1. This is half, that's half, that's half. Okay. Yeah. So let's, you could do it that way. Like if you notice the pattern, you can see if this pattern holds up, or the other way you could check to see is, are each of these points on the line? So over 1, up a half. Yeah, that could be right. Let's keep going. Over 2, up 1. Yes, for sure. Over 3, up 1.5. That looks about right. Over 4, up 2. That's definitely right. Okay, so yeah, I'm going to say that works. And then it moves at a consistent pattern. So, okay, for this one, it went over 2, up 1. Definite point. Over 4, up 2. Definite point. Over 6, up 3. Definite point. Over 8, up 4. Definite point. So right off the bat, Alex and Claire, the easiest way to write why they're correct is Alex and Claire are correct because each of their points lie on the provided line. Okay, so when I checked their points, they were all on this graph, right? Okay, or if you like seeing the relationship between these and then you can see the relationships there, sure, why not? Okay, but this one, even if you were to check by the graph, okay, yes, 0, 0 hits, but over 1 up 2 is here. That's not part of this line. So already you could have stopped and said, nope, Brian's table is wrong. So Brian's table is wrong because his points do not fall on the provided line or on the graph. Okay, pretty doable, right? Let's take a look at the next problem. Okay. The next problem says, Edward sells tacos for $2. The table below shows how much money Edward earns for each taco sold. Okay, and they were nice. They even told you that tacos sold is X and money earned is Y. Well, what do they want us to do? Okay, they provided the graph. They gave me the word problem. And then it says, well, 4 students tried to create graphs from this table, but they all look different. So who's right and who's wrong? If they made a mistake, explain what they did wrong and why they're wrong. Okay, I definitely want you to pause the video, try these yourself. If they're correct, just put correct. If it's wrong, put why it's wrong. Okay, you paused it, you unpaused it, you're back with us. Let's see how you did. Okay, the first one, X is the horizontal axis. So the tacos sold, yes, that's on the x-axis. Money earned is y. Let's do that first. Tacos sold, money earned. Tacos sold, nope. Okay, that already we can say is wrong. They switched the axes. Tacos sold, money earned. Okay, so incorrect. The axes are switched. Okay. So those should be relabeled, right? Okay. Let's check this one. So over 1 up 2. Over 1 up 2, yep. Over 2 up 4. Over 3 up 6. Over 4 up 8. Over 5 up 10. Looks like it would hit. Perfect. Correct. Okay, this one, like we already checked that these were labeled the axes correctly. Let's see if they did their points right. Over 1 up 2. Nope. Incorrect. I wonder, okay, instead of 1, 2, did they do 2, 1? Over 2, up 1. Yep. Okay, so they, the reason they're wrong is instead of going over 1, up 2, they flipped it and they did over 2, up 1. So he switched his X and Y, meaning instead of 1 comma 2, he did 2 comma 1. All right, and then this last one starts at 0, 0. Let's see, over 5 up 10. That is part of my table, yes. Okay, my next point is over 10 up 20. Over 10 up 20 is also part of my table. So yeah, since it's a perfectly straight line, you know it's going to follow a good pattern. So this is correct as well. And you're like, but wait a minute. Like these two graphs are both correct, but they look totally different. Well, this one is steeper because it goes up slower versus this one, like it's not as steep because it's going to take longer to get up to the Y because they're counting by tens this time. So they're not going to reach 10 as quickly as this one that's only counting by ones, but it's still representing the same data as that one. Okay. Hopefully you did fairly well on those. Last concept for today. Are you ready? Turn the page. Oops, next page. Okay, you have a chance to redeem yourself if you didn't do too well last time. Okay, because you have one more example problem. Are you ready? You got this. Okay, pause it, try it, unpause it, and come back. Okay, you're back with us. It says Trisha owns a dog walking business and charges $10 per dog. The table below shows how much money Trisha earns per dog she walks. Okay, so X is the number of dogs she walks, and Y is how much money she earns, because how much money she earns depends upon how many dogs she walks. Okay, so Y is money earned. So money earned, nope. Money earned, number of dogs walked. Money earned, yep, money earned. Okay, so this one is the only easy one that I can cross off right off the bat, because they switched labeling the X and Y axis. Okay, the next one went over 10 up 1. So over 10 up 1. No. Okay. Incorrect. I wonder if instead of over 1 up 10, did they do over 10 up 1? Yeah, they switched the X and Y. Okay, so switched her X and Y. Instead of doing the actual point of 1 comma 10, she did 10 comma 1. Okay, the next one. Over 1 up 10. Yep, that's the first point. Over 2 up 20. Yep. Over 3 up 30. Uh-huh. And then I can already tell like it's moving in a perfectly straight line, and these 3 points are part of the table, so that's going to be correct. Okay, and then my next one, it's over 1 up 10. Yes. Over 2 up 20. Yes. Over 3 up 30. Okay, I seem to have just said that before. Over 1 up 10, over 2 up 20, over 3 up 30. But why do these look so different? Because if you notice, this was counting by fives and this was counting by 10. So this is a little bit steeper because it can get there faster because it's counting slower, versus this is counting as bigger numbers. So it's going to take longer to get up to those. So it's not as steep as that one, but they're still hitting the same values. So these are actually both correct. All right. Congratulations, my little mathematicians. You've mastered being able to put a table to a graph and back and forth and seeing if a table matches a graph or if a graph matches a table. You should be very proud of yourselves. You got this.